I will talk today about semantic process innovation, which has a bit to do with emerging technologies. You may have heard of the semantic web. So it has to do with the semantic description of data and how it relates to processes. I will describe a couple of case studies. Many of them have to do with an organization in the United States government that sits in a building with 5 corners. But I will lead off with a little quote from Italo Calvino, who wrote a book called Invisible Cities in 1972. And if you haven't read it, it's a very nice book where Marco Polo meets the emperor of China and explains to him how all the cities in his vast empires look like. And he comes to the city of Fedora, and the city of Fedora is a city of possibilities. In the city, there's a building that has glass bowls, and in each glass bowl there is a model of the city, but not a model of the city that exists. It's a model of the city that could have existed if certain decisions had been made in a certain way. And so every citizen of Fedora was thinking about how to make the city better and built a model of what the city would like if it was better. But while they were building the model, the city already changed. So their assumption about what was possible was already invalid by the time they were done building the model. So what does this have to do with business process management and enterprise architecture? It basically characterizes the problem that we have with changing organizations. When you try to change an organization, you draw up a plan, you create lots of models. And when people ask me what I do for a living, I say I draw boxes and arrows. And by the time we are done drawing all these boxes and arrows, reality has changed. And we have to revisit our assumptions. So the book is 40 years old, and it's not an information systems book per se, but it's very, very adept at describing the problem that we face with information systems. So I came here yesterday, and I noticed that you can best describe an organization or the maturity of an organization and how it reacts to situations that are unexpected. Or what do you do when things don't go well? So when you start out as an immature organization, you have lots of exceptions because there's no clear standard best practice of how to do things. So everything you do is an exception. And then over time, you grow a core of best practices, a core of operations that is repeatable, that is streamlined, that is efficient. And as that grows, what happens on the fringes are still exceptions. And good organizations are very adept at dealing with them. So you recognize this is an airport, so you can probably guess where this is going. It's a sob story about an airline. So let me talk about an event sequence. When I flew here, I flew with United and Copa. And United had a plan. So the plan for United was that they have one plane that flies from Houston to Panama, and then back from Panama to Houston, and then from Houston to Panama. Right? It's flight United 1034. It leaves Houston at about 3:12 every afternoon and gets to Panama at 7:15 in the evening. Passengers get off, the crew sleeps overnight, and then the next morning at 9:55, the same plane flies back to Houston as flight United 1031. Then they have a crew change there, board passengers, and at 3:15, again, they fly back to Panama, and so it goes. That was United's plan. And my plan looked like this. So I flew from Newark to Houston, and then I would take this flight from Houston to Panama City, so I overlapped with United's plan, and then I would take the flight from Panama City to Santiago. So that was the plan. And the best laid plans hold up until the first contact with the enemy. So what happened was that on Sunday, flight UA 1034 left Houston about half an hour late. I guess you know that's our margin of error. And there were thunderstorms in Panama City. So they didn't land in Panama City. They were diverted to Cartagena. And then they waited in Cartagena. They landed in Cartagena shortly before 9, and they had to wait for about 2 hours until the thunderstorms cleared, and they got into Panama City at about midnight. And by the time They were deplaned. By the time the crew was debriefed, it was clear that there was not enough time for the crew to get enough sleep and be back on the plane to fly back to Houston on schedule. So they had to delay departure due to forced crew rest. And the flight left Panama City at 2:46 in the afternoon instead of 9 o'clock in the morning with a 4-hour delay. And ultimately, the flight then from Houston to Panama left at 7:35 in the evening. And I'm just putting the flight from Panama to Santiago in here so you can imagine what happened to my schedule, right? So if you're an airline, is anybody here working for an airline? No. Okay, then I can negative. So if you're an airline, then this is not an unusual phenomenon. Things happen. There's weather, there are mechanical difficulties, there's a crew that parties overnight and doesn't show up for the flight. So it's a question of how you deal with the situation. So here's how United dealt with it. They sent me an SMS even before I left Newark, 2 hours before my first flight, letting me know that my flight in Houston would be delayed. And when I got into Houston, I had a customer service representative there who booked me a hotel, gave me a meal voucher, and arranged for me to be put on the next flight to Santiago, which left Panama the next morning. I left Houston 10 minutes after my plane took off. My email inbox received an email from United apologizing for the delay, saying, please click this link and pick your choice of compensation. Do you want 7,000 extra miles? Do you want a $150 flight voucher? Do you want 10% off your next flight? You choose. We'll give that to you. Right? So, meal voucher, excuse email. Things happen, but it's a matter of how you deal with them. And if you think about this scenario in terms of these sequences, a lot of it has to do with process, but a lot of it also has to do with data and events. And Michael was talking about this earlier, that when you think about social signal processing, we're dealing a lot with external events to our business. How do we detect them? How do we classify them? How do we react to them? So what happened here was there was a detection of the exception. There's a deviation from schedule. I need to find out who is affected by that. So what's the passenger list on the flight that's been affected by that, or the multiple flights that are affected? And what is the severity of the exception? Are they delayed? Are they going to miss connections? Then I have to classify parties. So what are my most heavily affected parties? What is their frequent flyer status? What is the booking class that they travel in? What is their overall complexity of the itinerary? What can I do for them? I can do nothing. I can rebook them. I can reroute them. So I was offered actually to fly from Houston back to Orlando, then to Sao Paulo, and then to Santiago, which I declined. Then if something is feasible, do it automatically. Don't let the passenger worry about it. Communicate it to the parties that are affected, and if there's anything left to do, then engage the party. Right? So a lot of these things have to do with identifying the event and classifying objects. It's classifying customers. Your airline knows you're a frequent flyer. Your airline knows which class you have booked. They know your entire itinerary. They know where you want to go to, ultimately. So processes in this sense are sources and targets of these events. So you have operational processes that are going on. You're flying planes, you're loading passengers, you're unloading passengers. You're monitoring these processes. If something doesn't go right there, you detect the event. The gray part in the middle has to do with data. But then down here, I have an exception handling process for determining feasible actions. Check whether seats are available on alternative flights. Check whether hotel space is available for people that have to stay overnight. I have an operational process to handle these things. I have a communications process to communicate the incident, and then I have a manual process if I need to engage the party. So this has to do with taking events, classifying data, and then triggering the right processes. So this was timely because it happened to me the other day, but there are companies that are very good at doing this on a continual basis. Is anybody here working for a telecom company? No. What are the two things that telecom companies are good at? What is the best process in every telecom company? Sales? Billing, yes. Telecom companies are excellent at taking your money. Yeah? Their billing processes are world class. And the other process that they're good at arguably is connecting calls. So that happens reasonably well, unless you have an iPhone, but that's a different story. But yeah, it's billing that they're really good at. And the thing is, most of them don't do the billing process themselves. There's a company called Amdocs that does billings and operations management for most telecom providers. And they use semantic technology to figure out what's going on with their customers. So what they do is they get the call information. They know who you're calling, when you're calling. Maybe they know why you're calling. I don't know that. And they know what your bill is. They know how many text messages you send. And they use this information to build a profile of their customer in the database. They try to infer things about you that you didn't tell them explicitly. It's called predictive analytics. And then they use this information to inform their call center agents. So when you call your telecom company about a billing issue, typically you get picked up by a response system that says, if you want to continue this call in Spanish, press 1. If you want to speak English, press 2. During that time, they look up your phone number, they know who you are, and they try to figure out why you could be calling. Is it the end of a billing cycle, and maybe you have an expensive bill, so you want to switch plans? Is it time for you to get a new phone, replace your phone? What is the most likely reason why you're calling them? Did you have 3 calls that got dropped lately? Do you want to complain about the service? So they make this assessment, what could the possible reason be for you to be calling? And they give possible actions to the call center agent even before they pick up the phone to talk to you. Yeah? So their architecture, they call it See, Think, Act. Yeah? The C part is their event collector. So they catch events from revenue management, that's billing. They get events from the ordering system. Maybe you have placed an order for the new iPhone 5 and you're wondering why you haven't received it yet. And they have input from the customer relationship management system. Maybe you've called them twice in the past week and you're still not happy with the resolution. They take these events in. They know there are certain scheduled events. So I know how long your contract runs. I know when I send you the bill. There are certain recurring things that are happening. And they throw all of this into something called a semantic inference engine, where they apply business rules to it. And based on that, they feed this information to the customer relationship management system to provide some intelligence to their agents. So where is the process in this? There are many processes that go on here on this side that I don't really need to know about in detail. I don't need to know what the processes are, but they spit out events, and I need to collect these events. And there is a technical process going on in the middle that goes from left to right here. That's where my systems engineers worked really, really hard to put this together. And then I have operational processes here on the right-hand side, CRM processes that I trigger. I sell things, I fix things, I change billing issues. And the better I get at this model, the more proactive I can be in interacting with my customers. So my wife sends lots of text messages. And we have a block of text messages that is paid with our monthly contract. But for the last 2 months, we went over this allotment. We sent more text messages. Has that ever happened to anybody here? Yeah. It can get expensive. But what happened with my cell phone provider, they sent me an email and they said, we noticed you have 200 text messages in your contract, and for the last 2 months you went over these text messages. Here's maybe you want to add a larger package to your contract. Click on this link, and if you want to do that now, by the way, we'll make it retroactive and cover the last month so you don't have to pay the overages. Because I pay my bills on time, we've got 2 phones and a Wi-Fi hotspot, we're probably classified as nicer customers, they do that to us. If you are not one of their nicer customers, I don't know if they send you that email. No? Another thing that's happening, and we heard about Twitter in Michael's presentation, and sorry, this slide isn't in the handout. There are business process management vendors, this is Vitria here, that build solutions for social network monitoring and social media monitoring. So what they do is they collect tweets from Twitter that mention your product, your company, some of your service representatives, and they perform an automatic sentiment analysis of what is going on in these tweets. Sentiment analysis means that every word I use can have a positive or a negative meaning. Yeah, so if I use wonderful, that would get a positive sentiment score because it probably means good, and horrible would get a negative sentiment score because it's a negative word. So they monitor these tweets, they classify the words in the tweets, and they give them a sentiment score. Which of these tweets are positive? Which of these tweets are negative? Which of them are neutral? You see here there are slightly more positive than negative tweets in this case. You can see the overall score, you can see the development over time, you can see the actual tweets that were mentioned, and you have a mechanism to tweet back, to react to that customer in real time. So this is the technology, and Michael showed the example of Air New Zealand reacting to the customer asking for a quote. This is a similar technology that you would use to intervene in a social media stream before it spirals out of control, before it gets replicated 10,000 times that your customer service isn't as good as your competitor's customer service. Now for something completely different, okay? I would like to ask you to remember these 4 objects any way you like. And there will be a point in this presentation where I will ask you what these 4 objects are. So give it a second, have a look at them. I'm not going to tell you now what this is about, because I have to keep your interest a little bit, right? It's after lunch and you may want to nod off. Okay, and I want to get to the heart of this presentation. So the presentation is called Semantic Process Innovation. So with semantics, I mean the meanings of words, the meanings of phrases, the meanings of sentences. So semantic process analysis, that is semantics. What's the definition of a process? Yeah, this whole day is about process and enterprise architecture, and we can probably bring up 35 different definitions of what a business process is. But I like Michael Hammer's definition of what a business process is, because he says, if it does not make 3 people angry, it's not a business process. Yeah? This is important. Who are the 3 people that a business process makes angry? It's typically the person receiving the results of the process, the person performing the process, and the person that is responsible for the performance of the process, or accountable for this performance. But what it also means is that when we talk about business processes, we do not talk about technical processes that deal with systems integration, where no people are involved. We're talking about human-to-human processes. It just needs to be a certain level of abstraction. And then finally, innovation. You had a wonderful presentation on ways to innovate processes. So innovation is making changes to something that is established. And a lot of innovation works according to the schema that you start from an as-is state and you say, a miracle occurs, some magic happens, and we get to a result. Yeah? Okay. So I want to tell you a story in 3 parts. The first part has to do with modeling, drawing boxes and arrows until the ambulance comes and takes you away. Yeah? The second part has to do with the carp. And the third part has to do with semantics. and semantics has to do with words. So before we start, we have to talk about business processes in the large and enterprise architecture. So what is the architecture of an enterprise? Most businesses are set up like this. You've got an operational system where people do things, and you have a management system where people decide things. Yeah, it doesn't matter which industry you're in, or even if you're in private industry or you're in government. People do things. You've got the operational system, and you've got the management system where people decide things. And you take goods and services from your suppliers, and you bring them to your customers, and your customers give you money for that you channel back to your suppliers, and hopefully you keep some of it in the middle. Those are our transactional processes. And these transactional processes are very well understood and very well automated, and we can build standard solutions for that. You can buy enterprise resource planning packages for them. We got that. So we've got operational information systems that support you there. But then you have to make decisions. Should we invest in a new product line? Should we open a new location? Should we expand to a different market? So you collect reporting information from your operational information system, and you try to make decisions through a planning and control system, and then you give directives back to the operational information system. This is another form of process management. A lot of people think about business process management as managing your operational processes, your transactional processes. But the second form of process management is really managing your processes through a decision-making loop. And this decision-making loop is less mature than managing our transactional processes in most organizations. So when I talk about semantic data management and the things that Amdocs does and the things that United did, it has a lot to do with sensing a situation, getting proper reporting data, making a decision, and then deciding on what to do. So what do businesses do? Gary Rumler said a business really does three things. You sell stuff, you deliver stuff, and you make sure that you've got stuff to sell. Yeah? And that could be products or services. Or if you want the English terms for that, you have customer relationship management, you've got supply chain management, and you've got product lifecycle management. And they're all delivered through a facade that looks a bit like this. Yeah? He wants to make you a deal. In the 1960s, your business looked like that. Well, maybe not your business, but a lot of businesses looked like that. So what I mean is you had defined capabilities. The products and services that you offered were well defined. You had very well-defined processes and very well-defined endpoints, how your customers could engage with you. You had a brick-and-mortar location. Your customers would come and would talk to you, and you would deliver a product or a service either right there or you would come to their home. If you were a telecom company, you would go to their home and install the telephone for them. So you had defined endpoints and defined integration mechanisms. If somebody wanted to interface with you, there was a way to place orders, there was a way to receive shipments, etc. If you fast forward 50 years, Fortune 500 business today looks like that. It's Mark Zuckerberg on the right there. It's his office, Facebook CEO. So today you have evolving capabilities. What is the business that Facebook is in? Who knows? I don't know. Facebook probably doesn't know in much detail. So you have continual new service development. Facebook buys Instagram. Why? They want to have closer customer integration. They probably want to be on the site more often. Yeah, Facebook the other day did a switch where they replaced publicly displayed email addresses with @facebook.com email addresses. So you don't use your own email client. You go to Facebook to use your email unless you opt to change that. And yes, you can change it, but it's cumbersome to change it. People very often use defaults. Yeah? And a lot of these business decisions have to do with what kind of defaults do I offer to my customers so they don't have to decide for themselves. Yeah? I make the decisions on their behalf. What process? Yeah? A lot of these businesses don't start with a process idea in mind. There is no, there's operations, yeah, but there's no classic sales process in the freemium model. The customer goes to your website. If you want to use Dropbox, you download it, you install it. That's it. Yeah. The device evolution drives endpoints. Yeah, 5 years ago, there were no iPad apps. There were no iPhone apps as access mechanisms to most businesses. Now everybody has access to devices that exceed the computational power of a supercomputer 1995. Yeah. So device evolution drives endpoints. The next thing, voice recognition. Yeah, in the Department of Defense in the US, we're talking about how can we make Siri on the iPhone accessible to every member in the department in a way that you get all the information that you need, you get the insight that you need based on the situation that you are in. So I am negotiating with a supplier. I'm at the supplier's office, and I want to know what are competing offers that I could get? What is the typical price? Is the offer that I've just received from the person across the table reasonable, or did they put such a margin on it that I can't take it seriously? Drive the design of our processes. So Michael spoke about hiring at Infosys. The US military has a hiring process. It starts when you're on Times Square and you get drunk and you walk into the recruiting station and say, I want to join the Navy. Yeah? And then you go through a process that hasn't changed since 1914. So you express interest. You go through enlistment tests. It's basically a big multiple choice questionnaire. You go through medical exams. You become qualified, and maybe people say, okay, you can't carry 50 kilograms, but I want you for an office position, so that might not be necessary. You take an initial oath, and then you go into boot camp, and at the end of the year, 230,000 people complete basic training in the US military out of 678,000 that apply every year. And they have to come to the recruiting station multiple times, so there are almost 1.2 million visits every year. Similar problem to the problem that Infosys has. How do I cut down on the load in my business? And the new design, the concept of operations that they have is, you sit at home, you watch a sports event, let's say baseball, and there's an ad that comes up that says, go Navy. Join the Navy. So you go to the Navy website, you fill out your personal details, you give them permission to contact your insurance providers, the FBI, to pull your criminal records, etc. And they say, don't come, don't call us. We will call you. Yeah? And you go through an automatic pre-qualification stage so that only 250,000 go through the physical visit stage, and then still 230,000 come out as qualified at the end. So as Michael said, Infosys wants to hire every applicant. Yeah? And the US government wants to make sure that everybody who makes it past this first stage has a reasonable shot at becoming a soldier and lowering the load on their system. Yeah? And this is a model of working on the front ends that we see in other areas. So if you want to become James Bond, yeah, you can work for the Government Central Headquarters Services in the UK. So Government Central Headquarters Services is the United Kingdom intelligence agency. And they put this website up. I think it was just called breakthecode.co.uk. And they gave you a cryptographic puzzle. And if you solved it, you just had to put the solution word in here and click submit. I'm not quite sure if you had to enter your email address. They probably could find you anyway. But the idea is that you make the barrier of entry very high, and you know that everybody who makes it past this screen has already the basic qualifications that you have. So the point I'm making is this. We have processes in our organizations that are very well understood. Yeah, we know how to do accounts payable, we know how to do accounts receivable, we know how to do supply chain management and all that. The innovation is happening at the fringes, at the front end of the process, how we enter new cases, or during the exception phases. What do we do when things don't go as expected? Yeah, I can try to standardize my processes, I can try to normalize them as much as possible, but what do I do with the cases that just don't quite fit that I'm dealing with? So to do this, we built models, lots of models, boxes and arrows. And a lot of the models we built have to do with explaining the past. How does our recruiting process work? Yeah? How does my supply chain look like? How does our sales process work? So I built models to explain. I might also build models that look into the future. So I build models that constrain behavior. I will show you what's possible, and if you deviate from this map, if you deviate from this path, you're going to be in violation. When we speak to the banks in New York, to JP Morgan, to Deutsche Bank, to Citigroup, and we ask them, why do you do business process management? They say 80% of the time for compliance reasons. Yeah, performance is okay. We have the performance. Yeah, we do microsecond trades. But for us, it's when the SEC comes, the Security and Exchange Commission, and asks us, do you understand your business? And do you work according to a plan? And can you prove that you worked according to the plan? We can point to these models and we can say yes. So we constrain, or we guide, or we predict. And so predictive models, those are the holy grail. Now, there's a statistician, George Box, and he has a famous quote that said, all models are wrong, some models are useful. So in the military, we would say, don't confuse the map with the territory, right? When you create a business process model or an enterprise architecture model, it's a model. It has certain assumptions, but it's not the business, and it's not your process. Yeah? Our friends from Eindhoven who do process mining research learn that because they take actual traces of what people have done and compare them to the assumption of what people should have done. And they find that very often they don't match. Yeah? Michael calls this the difference between the as-is process and the as-if process. Yeah? Most of the models that we build are as-if processes, as if the world was ideal. So modeling is a bit like theory. It's a bit like building a model, how did this work, or how will this work, or what do I need to do to make something work? And the models that we build, we either build them for a purpose that we can anticipate, so it's like a design-to-order model. I need to introduce a business process management system. In order to make this system work, I need to map out my business process with all the integration points to software, so I know what this model is going to look like. Or I have unanticipated uses, and then I use reference models. So a lot of companies are interested in getting more mileage out of their modeling efforts. They create these libraries with thousands of models, but what they find is nobody looks at them. Yeah? And the people that created these models, people don't want to have lunch with them. Yeah? They are going, they're going to a different table in the cafeteria. So there are a couple of guidelines that we can follow to design better models. Models have to be correct in the first place. So these are 6 guidelines. The green ones are essential, and the red ones are optional, if you will, or supplemental. Yeah? The essential ones mean your model has to be correct, which means it cannot be that you switch the sequence of activities. It cannot be that you misrepresent reality. The model has to be relevant for a purpose. So it could be that I want to build my model for software integration, but I don't say anything about data in the model. Then there are certain things that are missing from the model. And of course, I want the model to be economical. I don't want to spend $50,000 developing a model that saves me $25,000 in the application. Yeah? So the US government found itself in this situation that in the business mission area, which I support, they have 2,000 different systems. And each system has an architecture. And each architecture is comprised of models. Many, many models. And these models look like carpet weave diagrams most of the time. And they are built in different tools, using different languages. And if I want to connect 2 systems, I'm going to hire a consultant that's going to build yet another model, the integration model, and I'm going to spend at least $250,000 for the integration. So they said, how can we get people to speak the same language to build the same models? We need a standard. We say the nice thing about standards is there are so many to choose from. So the typical situation is you have 14 competing standards. You're not happy with the situation, so you develop a new one. So now you've got 15 competing standards. Yeah. That's not going to work. Yeah. So how many standards do you know in the area of process modeling? We have BPMN, we have IDEF, we have event-driven process chains, we have Petri nets, we have flowcharts, we have SIPOC diagrams. The list goes on and on, right? So we certainly don't need yet another notation for modeling processes. So we took a look at BPMN and said, BPMN, let's just make the decision, BPMN is the most modern standard for mapping out processes. We're going to use that. Which part of it do we want to use? You have more than 50 symbols in BPMN. Yeah? And I'll give, I'll give $5 to the person that can explain to me the meaning of the intermediate non-aborting signal event. People who studied in Eindhoven are accepted from that. So we did this study of how people use BPMN. And I'm going to skip this. Ultimately, what came out, they don't. There are certain parts of BPMN that are never used. There are certain parts of the language that are sometimes used, and then there are certain parts that everybody uses. So the solution for us was not picking a new standard. The solution for us was taking an existing standard and making it work. So we took BPMN, and we said, everybody needs to know the green bit. And people who do software integration need to know the green bit and the blue bit. And we don't care about the red bit. So you can make that a guideline in your organization, and you can develop a design standard around that. So that's what we did for the Department of Defense, and this is how it happened. So we did this analysis of BPMN use in 2007. We took several hundred models from different sources, and we came up with this frequency analysis, came up with a common core. So based on that, we defined a BPMN subset that we called the primitives, the BPMN primitives that we said, this is the subset that we are going to use. And then we engaged the object management group, the standards body that defines BPMN, and said, in the current version of BPMN, I only have the choice between everything or nothing. And I want to have the choice to say, I'm going to use BPMN light, not everything. So we worked with them for a while, and what happened was they put a revision of the standard out, and in the revision of the standard, they introduced something called conformance classes. And they said there is a small conformance class if you only want to draw models like flowcharts. There's a medium conformance class, the analytic conformance class. That's our green box and our blue box. And then there is BPMN full. So you have the choice between that. So BPMN 2.0 with conformance classes came out in January of 2011. January 2010. Now, we were working for the Department of Defense, which is a large organization. They don't adopt a standard like that. We had to add BPMN 2.0 to the Enterprise Standards Registry. So the Department of Defense has this registry that says there are certain technology standards that we support. So BPMN had to go in there. So we had to wait until it was officially published, until it could go in there. Then, having it in the registry is nice, but this is the government. Nobody in the government does anything unless you have a mandate. So we had to work with the Deputy Chief Management Officer to write a memo that said, whenever you do enterprise architecture, whenever you do a system architecture, you will use BPMN for process modeling. That memo came out April 4th last year. Then, of course, you have the affected components, the ones that received that memo that said, that's all nice of you to say, but who is going to train me in this? So we had to develop a training program around that. We developed BPMN2 training, and at this point we sent about 400 people through this training program. It's a 2.5-day training that qualifies them in the use of this. And so ultimately now we're beginning to see a skilled workforce of analysts and engineers to do that. Hey, it only took 4 years. Yeah. So it may, for private business, that's a glacial pace. For government, that's like a Formula One race. Yeah. But generally speaking, this type of process is one that you would go through if you wanted to pick a design standard, pick an architecture standard, and make that useful for you. You know, pick the standard, pick the things that are useful for you, and then mandate it in the organization. So now we're going on to unexpected road, because I said I was going to come back to these 4 objects that I asked you to remember. So what were they? Okay. Orange, watermelon, soccer ball, football. How did you remember them? Okay, so some people may have used shapes. So they said, hey, there are 2 things that look like a circle, and there are 2 things that look more or less like an oval. Yeah? So who used shapes to remember them? Yeah? Okay. Another way to remember them might be you would say 2 are fruits, and 2 are pieces of sporting equipment. Right? So 2 sport, 2 fruit. Who remembered it this way? Okay, more like that. Okay, so why am I showing you this? It has to do with this gentleman. His name is Christopher Alexander. He's an architect, or an architecture critic. And he wrote an article in the late 1960s called "A City is Not a Tree." And basically his hypothesis is that we are really bad at designing things that have overlapping concepts. What do I mean by that? So if you look at this structure here, this is a tree. So I've got 5 things here, 1, 2, 3, 4, 5, and then I combine them, and everything can only have 1 parent. So 1 and 2 get combined to 1, 2, 3 and 4 get combined to 3, 4, and then 3, 4 and 5 get combined to 3, 4, 5, and everything comes together to 1, 2, 3, 4, 5. A simple tree. Now imagine if I flipped this over 90 degrees, and I looked at it from the top. If this was a mountain range, it could be represented like this. Yeah, or set theory if you're a mathematician. So I've got 1 and 2, circle them as 1, 2, 3 and 4, circle them as 3, 4, 5, 3, 4, 5. Yeah. So if you started with 3, 4, 5, if this is your enterprise and you try to classify the things in your enterprise, you start drawing boundaries around them. And you start to draw them into circles, and this is essentially what you end up with. Now let's make one little change here. Okay? The change that I'm making is that 2 now has 2 parents. So I'm moving from a tree to a semi-lattice. So 2 is now a component of 1, 2, and it's also a component of 2, 3, 4. And what's the major difference between the previous picture and this picture? There's overlap. Yeah? And so in remembering our 4 objects, your ontology, or your categorization was either it's a fruit or it's a ball, or it's round or it's oval. Yeah, that was the taxonomy that you used. But when we say, okay, it's round and a fruit, it's round and a ball, it's oval and a fruit, it's oval and a ball, I'm starting to mix concepts. I'm starting to add up with a space that's overlapping. With 4 objects, that's okay. But as you add more objects to it, it gets more complex. Yeah, so in our example, the picture would look like this. So the problem is that when we look at the world and when we try to model the world and we build models of the world, we want to put things into buckets. Yeah? We start with a business architecture. We put everything into buckets. Inside the business architecture, we have processes. So we put things in process buckets. Inside our processes, we have activities. So we put things into activity buckets. Our activities use services. So we put things into service buckets. It's wonderful. It's a tree. There's no overlap there. Yeah? Everything decomposes very nicely. But that's not reality. Reality is messy. Reality means lots of things overlap. Things have multiple purposes. And so that's why I'm saying that the map is not the territory and the model is not reality. Our models are always simplifications. So the semantic part of this presentation has to do with the fact that I want to start with a vocabulary and then want to build models with interesting words. So what do I do if I start from the bottom up instead of starting with abstract concepts that I refine and decompose? So let me illustrate my point here. And I'm going to use an example of enterprise architecture. We build enterprise architecture mostly to talk about it. Yeah. How many of you have built an enterprise architecture that you've actually implemented? 0%. We build enterprise architecture so we can have a conversation about our business. We understand where we are. This is your area. This is my area. This is what the interfaces are. But ultimately, business has to work. So we want to build systems and services that talk to each other. So this is what an enterprise architecture can look like. This is something when Michael and I were still in Germany. We're perfectly qualified to talk about process because we follow the rules and everything is orderly. And this is an architecture that was built at our department for a retail company. Or basically, it's a reference architecture that fits all sorts of businesses, but predominantly retail. You have contracting and purchasing from your suppliers on the left-hand side. You receive goods in the middle. You store them in your warehouse, and then you ship them out. And you've got your accounting and billing functions below that. So it's a nice compartmentalized architecture. You take the business, you put it into this H structure, and in German it's particularly adept because retail in German starts with an H, it's Handel. And then you would drill down into each of these boxes and you'd find the relevant data models, you will find the processes behind it. But there are other dimensions behind this that are not shown in the picture. For instance, everything that's on the left is supplier-facing, everything on the right is customer-oriented, and I can mirror this picture multiple times. So my marketing function talks to my supplier's contracting function. My sales function talks to their purchasing function. My shipping talks to their receiving. Those are my business-to-business processes. Yeah, there are interactions here. I also have an assumption that there's a certain frequency of operations going on. So what I do in terms of contracting drives what I can purchase. What I purchase drives what I receive. What I receive drives what invoices I receive. What invoices I receive drives what payments I make. And on the customer side, whatever I market, it drives my sales. What I sell, I have to ship. What I ship, I have to write an invoice for. What I write an invoice for, I have to track and follow up on the payment for it. So there are things that happen less often at the top and things that happen more often at the bottom. And I come back to the 3 fundamental processes. I sell stuff, I deliver stuff, I take the money that go across this picture. So depending on who is looking at this architecture, for what purpose, they may see different things. It's not the same picture for everybody. Yeah? But it's a nice map of the territory. So lots of businesses have things like that. The retail architecture is just an example for a retail enterprise, but this is an example from Siemens. So Siemens has several hundred subsidiaries worldwide, and every single one of their subsidiaries has this enterprise map that says, these are the things that we do. We have customer relationship management. We plan, we understand, we sell, and we care for our customers. We have supply chain management. We source, we make, we deliver, we handle returns. And we've got a product lifecycle management here where we define, we realize, we commercialize products. Sometimes we phase them out. It does not matter whether you make light bulbs or you make CAT scans, whether you build nuclear reactors or you make monitors. Every business line of Siemens has to map their operations into this framework, and they use it as a global benchmark so that maybe the people who build light bulbs, they have an interesting concept on how to commercialize a new line of product, and that can, and the people that make medical devices can borrow it from them. So this is one perspective on enterprise architecture. But of course, you need to you need to combine it with a way how to get deep. Yeah, if you want to dive into this, basically jump through the screen and get to the individual processes that happen, I need to go through decomposition. So I may start with the business area and then get to end-to-end processes. So I have hire to retire, procure to pay, order to cash, budget to close. And then for each of these end-to-end processes, I have segments such as determine needs, select supplier, purchase goods and services that all belong to my procure to pay process. And then when I take my purchase goods and services model, I end up with my business process model underneath this. This is the decomposition we use in the Department of Defense. Other businesses go further. So here's an example of a decomposition that British Telecom is using. They have 6 levels. Yeah, they start with a balanced scorecard at the top and their business activities. They drill down to level C, where you have delivery units, actually who does it. And only at level D, they start introducing information technology concepts. So at level D, they have systems. At level E, they have system functions. At level F, they have the actual transactions that are happening. If you are introducing SAP or Oracle or another technical platform, you're probably looking at models at level F. But if you're talking about standardizing operations across different lines of business, you're more likely to talk about models at level C or level D. And they have very detailed guidelines on how to create models at each level. But the important thing for them is that at the top 3 levels, you talk about what you do. And at the bottom 3 levels, you talk about how to do it. It's the important distinction. Yeah? And so this transition from what to how is quite significant. Yeah. Now, we have a lot of technology that makes the how easier these days. Has anybody seen this car? It's called the Rally Fire. It's got a Chevrolet Corvette engine, 600 horsepower. It's got the taillights of a Honda Accord. It was designed through crowdsourcing. So this company went out to their potential customer base, said, what do you want our car to look like? What should the lines be? Here are a couple of design concepts. Get back to us with this. And you can buy this car for $60,000. So it's made by a company called Local Motors. This company has 10 employees. They have 10 employees because they've outsourced the design process to the crowd. And the manufacturing is done at local fabrication centers around the United States, just custom manufacturing. How many have heard of the company Tesla? It makes electric cars. Yeah? They make an electric sports car. It costs about $100,000. Everybody in Hollywood has one. But they don't make the car. Yeah, the car is made in the UK by Lotus. Yeah, Lotus ships the car to the United States. The only thing that Tesla makes is the battery and the controller software. Yeah, and then they integrate it. So because of the way how operational processes have streamlined and the standards that have emerged for the integration of these processes, we see complete shifts in business models. So this is a figure from Wired magazine a couple of years ago. The traditional model of car manufacturers was that they came up with the design of the car, they specified it in great detail, and then they told their suppliers, I need a battery that has this these dimensions and this voltage and these features. I need an air conditioning unit that has these features. I need, what else do we have here? I need an interior. I need seats with a particular design. And this has been turned completely on its head. So now the suppliers are the sources of innovation. I have Recaro that makes car seats. They develop new seats, and then they go to the car manufacturers and say, we've got this wonderful new seat. Do you want to design a car around it? Yeah, so the car manufacturers go to the suppliers, use the suppliers as a source of innovation, and the core competency of the car manufacturers is the integration of these different streams into cars. Yeah? And then they don't even make the cars themselves. Yeah, they go to companies like Magna in Europe that builds multiple cars on different platforms for different manufacturers. Yeah? We had a similar tendency in the semiconductor industry. Back in the 1960s, 1970s, if you were in the semiconductor industry, so you had to build factories with clean rooms, and it was very expensive. The capital investments were very high. Now we have fabless semiconductor companies that design the chips, but they don't make them. Somebody else has the factory, makes the chip for them. Completely new business models. So that's where, at the top tier of the architecture that we heard about in the first presentation by Professor Barros, where the business architecture level comes in. I have to decide what my business model is. Where is my core competency? What can I do well? What do I spin off? And how do I describe my interaction with these outside parties? So, coming back to the US government, we would like to be more agile. And the problem is we have many people sitting around the table that all have different questions about the business. We have different perspectives on it. Right? I come back to this picture. I said this is the operational information system, and the operational system, we do stuff, and then we decide stuff. And they're typically not the same people that perform both roles. Picture says more than 1,000 words. So I was flying in over Germany a couple of months ago, and I took this picture. So what you have here is the Rhine River, and there's fog in the river. And this is the perspective of the CEO, or the perspective of the board of directors. So here's your village of middle management, and then these are the trenches of operations, the fog of war. You don't really know what's going on there. You know, there are people working down here. So you try to make decisions as best you can based on the reports that you get from here. Yeah. Now, if you're down below, your world looks more like that. Yeah? You're confronted with the reality, with the complexity of day-to-day life, and you've got dark clouds overhead, and every once in a while the sky parts, and somebody makes a decision, and then the skies close again. You say, I'm not quite sure where this decision came from, but I'm a good soldier, so I'm going to implement it. So, and this is an illustration of the immaturity of the second BPM cycle, not operations, but decision-making. Yeah, so remember, the operational BPM goes left to right, and the decision-making BPM went in the circle across the top. So our problem here is, first of all, information quality. How do you know how well your organization is doing on a day-to-day basis? Do you get all the events that you need to get? Do you cluster them? Can you sense them? Do you know what they mean? The answer in many cases is no. I have bad information. Yeah, I worked with an insurance company that couldn't tell me how many car insurance policies they have. They ran different reports every month, and they got 3 different numbers. So each of the numbers was true based on certain assumptions. So you have a problem with information quality, and because you have bad information, how do you help your decision makers? You give them more of it. Yeah? I know this information is bad, so please take these other 2 numbers that I also know they are bad, but at least you've got more bad information to make better decisions. Yeah? So you deliver information overload. And the result is the quality of the decisions that get taken. So unless we solve this problem of understanding what's going on in our business and being able to sense, we're not going to solve this. Sounds a bit academic, right? So here's a colleague from New Jersey, Thomas Edison. And one of my favorite quotes is his, "Vision without execution is hallucination." Yeah. So there's a disconnect between what the people on the ground see, what happens operationally, and tracing these operations back to the original vision that people had of what they wanted the company to look like, what they wanted the business model to be like, what the customer wanted in the first place. So how many of you have a surround sound system at home? Stereo surround sound system. All right. Your surround sound system may look like this. It's probably the area that you don't look at most of the time, right? This is a software engineer's dream. Yeah, they see the world like this. They say, look at all these services. Yeah? And I've got so many standardized interfaces here. I can do so many things. I've got HDMI, I've got RCA, I've got SVGA. All the wires I can plug in here. Man, this is so flexible. This is my service-oriented architecture. So I actually bought this receiver. I made sure to never show this side to my wife. So I put it in the shelf, and it looks like this now from the front. So this is the architect's perspective. What are the high-level services that I have? I can switch inputs. I can switch between Dolby Digital and Dolby Pro Logic 7. I have no idea what the difference is, but it must be good because I can do it. And I've got this big knob for volume. So that they got right. That's what you want to do. So I was really proud. It took me all afternoon to set it up. And then my wife came home, and she saw 5 remote controls on the coffee table. And she said, either these go or the whole thing goes. Right? Because what my wife wanted was this, which is a universal remote control where you have one button that says, watch TV. And you have another button that says, watch a DVD. So, and because I listened to my wife, I'm a good husband, that's what we got. Yeah, I threw the remote controls out. But this is the disconnect. This is what the customer wants. The customer wants to watch a movie. The software engineer sees this. So how do you connect, I want to watch a movie, with the, is it better to connect via HDMI, or should I connect via component out? Yeah? Different levels of abstraction. So this traceability is important. And because this is an area of architecture that is not very well developed, we're not very mature at describing these needs, we need to come up with better ways to do that. And so I'm proposing this model that just has 4 aspects that I want to describe about a business. It starts with a capability. What is it that you want to do? What's the service that you want to offer? What do you want to be able to do? And in order to do that, what are the activities or the processes or the functions that you need to perform? And what do you need in order to do it? Is there any data that's input and output to these activities and processes? And are there any people or systems that you need in order to achieve that? If I can describe a system or my business with these 4 classes of information, I've already achieved a lot of integration. Yeah, and I can take it from there. So we introduced this term of vocabulary-driven architecture. Before we start drawing boxes and arrows, before I buy System Architect and I create these wonderful maps, I want to say, okay, what are my capabilities that I want to have? What are my objectives, my features, my services? Just use words to describe them. Sit down and come to an agreement what these words mean. Then define activities. What do I need to do in terms of verbs, in terms of actions, in order to achieve that? Once I have my actions, then I need to define my resources. What will be consumed? What will be produced? What are the inputs and outputs at this level? So I get nouns. And finally, who are my performers? Who's going to be responsible? Who's going to execute this? So I end up with something that's called carp. There's the fish. Now, in the first iteration of this, we had called it capabilities, resources, activities, performers, but we did not like the acronym. So what does this look like in practice? Well, very simply, we started with the number one business modeling tool that everybody knows how to use, Excel. Yeah? So we built a simple Excel spreadsheet where you enter a term and you classify it. Is this a capability that you're talking about, an activity, a resource, or a performer? And then here on the right-hand side, the different models in the enterprise architecture framework of the Department of Defense. And as you fill this out and you classify things, it will show you which models might contain the term that you have just defined. So if you fill it out, it looks a bit like this. So these capabilities, they will show up in a perspective that is called the OV5. And these terms here, these activities, they might show up in all of these models. What this does for me is it gives me traceability in two directions. It makes sure that I have defined all the words that I use in my models. And when I look at my models, I can go back and say, is there anything in this model that I haven't defined here? So, am I describing the world properly? This doesn't have to be complicated. We start with this and we fill this out with 20, 30 terms maybe at the beginning of a project. We look at these terms and then we start to build our initial concept of operation. So if I just take everything that I've defined as activities, here I can come up with a very simple milestone process. So here's an example. These terms were defined in my vocabulary, and I put them in a BPMN diagram. If I take them now, and I look at my capabilities, I use a use case diagram to describe my capabilities. So these things here, disseminate news, and my actors, which are performers, they have been defined in my Excel spreadsheet. So I know that I have a baseline to work from, and then as I add these things here, I add them to my spreadsheet, so everybody knows what I'm talking about. Same with data. My key data elements are going to be in my spreadsheet, and then I start building out the rest of my data model. And I can go into designing software around that. At the Department of Defense, architecture is built for different purposes. Yeah, but most of it has to do with answering questions. We have some questions that relate to our data. What are the business objects that we're dealing with? We have some questions that relate to process. When do certain things happen? What are my possible courses of action? And we have some questions that are related to rules. What can I and can I not do? The problem is that most of the architecture frameworks that exist out there are designed with a fixed set of questions in mind. So whether I use ARIS, or I use TOGAF, or I use DODAF, DODAF has 53 perspectives. Yeah, it's more than enough for anybody. But there are certain questions that I cannot anticipate. So we found ourselves in the situation that we had invested millions of dollars into architectures that were useless. And the question was, can I salvage some of this information? So that's where the idea of semantic enterprise architecture came into play. So what I have, so I've got architecture that is composed of models. Yeah? And these models have two components. I have the language, the modeling language that gives me the structure of the model. So if I use BPMN, I have boxes and arrows. Yeah? If I use class diagrams, I've got squares and arrows. If I use use cases, I've got ovals and arrows. But that's what my modeling language gives me. And then I have the stuff that I write into these boxes. So that's my domain content. What are my activities called? What are my classes called? What are my data objects called? That's really what makes the model. Yeah? We teach business analysts and modelers a lot about this. We teach them, how do you create a proper class diagram? How do you create a proper use case diagram? How do you create a BPMN compliant diagram that contains the non-aborting attached intermediate signal event? We don't really teach them much about how do you organize the domain content and make sure that that makes sense. Yeah. So when I look at my tools then, the model structure gets saved as model data and the domain content gets saved as a vocabulary. What do I mean by that? This is a BPMN diagram, as you can clearly see. Yeah? And there will be a test at the end. I will ask you what's in this line. So in BPMN, when you save a diagram, it gets saved in a language called XML, and this XML has two components to it. The first half describes the content of the process in sense of the business logic. So I know there is a start event here, or there is a process and it has multiple lanes and they may have names. And then the bottom half of the diagram has the layout of the process, which is the rendering information. It says, here is a box and it is this big and it is in the bottom right corner of the screen, and here's another box and it's slightly smaller and it's connected to the first box. Yeah? We're only interested in the top half. We're only interested in the business logic. This tool-specific stuff doesn't interest us. But yeah, so the model data is of interest for an engineer or an implementer, because every symbol in BPMN has a specific meaning. If I have a business process management system and I encounter an intermediate message event, my system will do X, and this X is specifically defined in the standard. But if I have an activity and the activity says, remind customer of overdue payment, the BPMN engine or the business process management system does not know what to do. Yeah? It cannot interpret that. This is something that domain expert needs to assess. What needs to happen there? So I have, in the Department of Defense, lots of architecture models with lots of emphasis on this part and very little emphasis on this part. But this is the stuff that's really important to the business. What does the business do? How are these things connected? So we look at this domain content and we say, okay, we have terms and concepts in my data models. I've got data objects. I know I have an invoice. I know my invoice has a sender. I know my invoice has a due date. I know the invoice has an amount. And I have certain constraints. For instance, the amount of an invoice should not be negative. So if that sounds like data modeling, it's because this is like data modeling. So we ask, can we take this information and can we use semantic technology to make it useful? Yeah, and semantic technology means name stuff. Yeah, give things unambiguous names. It's probably the best explanation of what semantics technology is about. So I look at my typical business process that I have. And my business process has my business semantics, the process semantics, what are the labels of the activities. I also have semantics that my modeling language defines. So what does this rectangle stand for? I have payload semantics. I've got information about my messages and my data that go back and forth. And I've got metadata. I know who created this process. What's the version? Is it still current? When was it last changed? Is this even valid, or is this a to-be design that comes online January 1st, 2013? And then I've got the layout, which is less interesting. So this top half is everything that I do during design time. And then when my process runs, I get my processing behavior and I get the actual instances. So if this is let's take insurance claim processing, since Michael singled out some of the attendees for that. If this is the design process for that, then at the bottom I have the execution. So I could give you theoretical examples for the semantic stuff, but I thought I'd better show you what you can do with it. So here I have a tool that is called Protege. It's an open source tool developed by Stanford University. You can download it from there for free. And what I've designed in this tool is a very simple ontology for business processes. So my business process consists of activities, it has resources, and it has sequence flows that connect my activities with each other. I have classified my resources into information, organization, role person, service, and system. So this is basically a data model that I have built. There's another way to visualize this. I can look at it like this. Okay. So this is the network of information. So I have this relationship that a system is a subclass of resource, and a resource is a kind of thing. So in ontologies, the things that at the top is always a thing. The world consists of things. Yeah? And so underneath things, I have activities, and my activities can be of different kinds. So an activity has a relationship to performer because an activity has a performer. I also have these things here with these diamonds, which are instances or so-called individuals. So enter applicant data is an instance of an activity or is a particular activity. What I get is network data. And the difference between traditional data modeling and this is that in my data store here, I have a data model and I have instances of the data model in the same structure. Yeah, traditional databases would separate them. I have my database schema, that's my table structure, and then inside my tables I have my instances, but they are two separate concepts. And semantic data brings that together. Now, where does this become interesting? So I have certain things here that are not standard BPMN. For instance, I have something that's called a decision activity here. So if I look at my classes and I look at decision activity, then I have a definition for what a decision activity is. It is an activity that has an outgoing flow, a sequence flow that goes out, that has a condition, or that is a conditional flow. So what that means is an activity where I have to make a choice whether I go a particular way or not, I classify as a decision activity. And conditional flow is something that's also not a standard object here. I have conditional flow, which is defined as a sequence flow that has some condition associated with it. So all very theoretical. But now let me show you the process model in question here. So this is the process I'm interested in. It's a very simple BPMN process. I enter applicant data, I review applicant data, and then I make a decision. I evaluate the applicant, and I decide whether I want to enroll the applicant in a course that we offer or whether I want to reject an applicant. Yeah. And my question is, who is the decision maker in this process? So using BPMN, can somebody tell me who the decision maker is in this process? You would say the recruiter is the decision maker. Okay. Good assumption. On what did you base your assumption?
The activity before the decision negation.
Very good. So you would say somebody who performs an activity that precedes a gateway where you make a decision must be a decision maker. Because the outcome of what this person does determines whether I go left or right in this process. So since you answered the question correctly, how did you come to your assessment? You looked at the diagram, right? You looked at the diagram and you found this activity and said, yep, this is the decision-making activity, so I look, this is the recruiter, so that must be the decision maker. So now you're Rio Tinto, and you've got 3,500 process models in your repository, and I want to know, can you give me a list of all the decision makers in your processes and what kind of decisions they make with the current tools that you have at your disposal? Well, you can print 3,500 diagrams and you can hire lots of MBE graduates from Professor Barra's program, and they will sit and look at these 3,500 diagrams and they will highlight all the decision makers for you. But there should be a way to do this more automatically or more easily. So that's where this semantic technology comes into play. So you see, I have taken this process that I showed you, and I've put it into this ontology as individuals. So I have sequence flows which are approved, entered, rejected, and reviewed. I have the activities down here: enroll applicant, enter applicant data, evaluate applicant, reject applicant, and so on and so forth. And in terms of my resources, I have various roles and people. So I've got Greg, Joe, Matt, and Michael. I've also defined some relationships. So in the semantic world, these are called object properties that relate to activities, and there are data properties. So I know who performs what. But for instance, I have defined my class performer as an organization, role, person, service, or system that performs some activity. And currently, there are no members here. So this is empty. So what I want to do now is I'm going to run a reasoner. And the reasoner is going to look at the data and is going to say, does this data meet certain criteria? And based on the criteria that it meets, I'm going to classify it. So I'll start the reasoner. Magic happens here. Okay. And now I'm looking at my inferred class hierarchy, and I see, okay, so performer, I've got Greg, Joe, Matt, and Michael, who are all performers. Why is Michael a performer? Well, Michael is a performer because he performs some activity. So looking back at my hierarchy here. And now if I go to decision maker, I can scroll down here and I can see that Greg and Joe have been identified as decision makers because they perform a decision activity. Evaluate applicant has been identified as a decision activity, because when I look at evaluate applicant, it does have an outgoing flow approved and an outgoing flow rejected, and these outgoing flows have conditions. So approved has been identified as a conditional flow, so that's why evaluate applicant has been evaluated as a decision-making activity, and ultimately Greg and Joe have been identified as decision makers. Now, it doesn't look particularly spectacular, but what this allows you to do is make inferences about models that you have created without creating new models or adding data to it. So you have an enterprise architecture, you have lots of information in your enterprise architecture, and all of a sudden you come up with new questions that you want to ask. And in the old days that meant, okay, call the business analyst and ask the business analyst to create a new model that answers specifically the question that I have. But now with this semantic technology, it means I take the content of my enterprise architecture, I stick it into a triple store, which is the data structure underneath this semantic technology, and now I can add questions. I can classify data, I can ask things, and I can ask that very rapidly. And so this is what MDocs does. MDocs takes events. Yeah, think back to the very first case study. MDocs takes events that have to do with the billing customers of the telcos, and it classifies these events through this inference engine very fast. And it takes the fact that the customer is calling now. What do I know about the customer? How do I classify this customer? And the classification of the customer may change from today to tomorrow. But with this technology, I can do this very, very rapidly. So who uses this besides MDocs? For example, the US Customs and Border Patrol Service. Because we have certain people that we know are travelers. Yeah? We know you're a traveler because all of a sudden you show up at the border with your passport. So you've come from somewhere. Now, we actually know more about you than that because the airlines send us the itineraries. And we have some travelers that might be travelers of interest. So those are people that where we don't just put the stamp in the passport, but we may ask a couple of questions. But we also have some people that are suspicious travelers. And so for the Border Patrol agent, it's a question of whether the person that shows up at the front of the line is a traveler of interest, or a suspicious traveler, and how many questions should I ask? Some people I know are suspicious travelers because I have them in another database as a suspicious person, right? So if you are a suspicious person and happen to be a traveler, then you're going to be classified as a suspicious traveler, and you're probably going to get some questions. Yeah? So they collect information and they ask questions. So the semantic technology is useful if you have a lot of data and you're not quite sure what you want to know. And you may add questions over time, and it helps you classify this information. So it's becoming a more and more mature technology. So we built an ontology for BPMN. This is our BPMN ontology. It's beautiful, isn't it? And what that allows us to do is that I have the modeling community that's interested in things like, okay, I have a task, and some tasks are manual tasks, and create purchase order is a manual task. So that's what my BPM community does. They create this part of the ontology. But I also have my finance and economics community that's interested in which tasks are value added and which tasks are non-value added, which tasks are risky, which tasks are environmentally dangerous, which tasks are compliance driven. So they have their own vocabularies and their own ontologies, and they may have something saying there's an economic concept, and value-added entity is a type of an economic concept, and create purchase order is really a type of a value-added entity in my business. So I can have different communities creating vocabulary of things that they are interested in, and then I merge these vocabularies through shared terms, and I can ask questions across. So this is not just an academic prototype, but we're using this in the Department of Defense to integrate HR data, human resources data. Because in the Air Force, a soldier in the Air Force is called an airman, and a soldier in the Navy is called a sailor, and a soldier in the Army is called a soldier, right? So if you wanted to know how many service members do I have in the military that speak Spanish, in the old days, you would have to go to each of these separate databases and query the database. You would have to understand what the database structure was, what the names of the fields were, what the different labels were called. Now what we do, we create a query ontology that says, okay, a service member speaks a language, and in the case of the Marines, it means this. In the case of the Air Force, that means that. In the case of the Navy, that means that. And we can ask the question once, and we get the results aggregated from all these different data stores. Yeah? Now, that might be a unique case because in the military, we deal with the separation of systems by law. Yeah? The US military tried to integrate their human resource systems in a 10-year project. It was called DIMERS. They spent $1.5 billion on it. It was the largest PeopleSoft installation in the world. And then they declared it a success and shut it down. So integration clearly didn't work, but federation does work. You've got these separate systems, and you find a way to ask questions across them. Okay. So you may ask yourself this question. So what? So my message is this. With the semantic approach, you can use ontologies to describe different domains. My data people can describe the data domain. My process people can describe the process domain. My HR people describe what they are interested in. The finance community describes what's a general ledger, what's an account, what's a posting, what are books. Yeah? And then I can bring this information together, and I can ask questions about it that I did not anticipate in the first place. And it allows me to classify environmental situations as my understanding of them evolves. So think back to the social sensing that Michael talked about. Think back to how United reacts to exceptions. Yeah, if you have unanticipated situations and you need to classify them, and over time your understanding of them evolves, this is good technology. It's still in very early life cycle stages. Yeah, there's a lot of voodoo there, and the one thing that you don't want to do is talk to an ontologist. Because ontologists, they all have ponytails, and they have a linguistic degree from MIT, and You just don't want to do that. Okay, so it's part voodoo, I guess that's what I'm trying to say. But we built several prototypes with this technology in 90-day increments. So 90 days, one concept until it worked, and then next concept, 90 days until it worked. And it is feasible. And Amdocs uses it with millions and millions of events every day. So it's clearly scalable. So I started with Calvino, and I want to end with Calvino. Marco Polo explains to the emperor a bridge that is composed of stones, stone by stone, and the emperor says, I don't care about the stones, I care about the arch of the bridge. Why do you describe the stones? And Marco Polo answers, without stones, there is no arch. So the reason why my presentation was at different levels of abstraction. We started with architecture, we went through modeling, and then we went into the weeds of the semantic technology, is because I think that this concept of semantically describing data, you will see that more frequently. It's going to become one of the tools in the arsenal of IT, and it's going to become one of the building blocks of your business intelligence and analytics infrastructure of the future. And it can have an impact on how you innovate your processes. So with that said, I'm going to leave you with those thoughts. And if you have any questions, I'd be happy to entertain them. Thank you very much.
Me interesa validar lo que ha dicho, debido a que en varios proyectos que estamos realizando hemos encontrado que el modelamiento semántico es útil para representar conocimiento experto en situaciones en que otras técnicas no son posibles. De hecho, hay un caso que se va a presentar hoy día que usa el modelamiento semántico para efectos de describir un dominio que tiene que ver con proyectos desarrollados por expertos. Pero también hemos encontrado en procesos médicos que hay conocimiento médico que no hay otra manera de expresarlo que con modelamiento semántico, de tal manera de que a partir de ese modelamiento semántico uno pueda expresar reglas, en último término, que se desprenden de ese modelamiento semántico para efectos de poder decidir acerca de ciertos aspectos médicos que se dan cuando uno procesa pacientes. Entonces, yo creo que esto es algo muy interesante y que yo creo que tiene mucho potencial para situaciones poco estructuradas, en las cuales el conocimiento es difícil de describir por otro tipo de técnicas más precisas.
Thank you. I'm glad you made that reference to the medical domain, because that is where we have lots of talks with people at the Mayo Clinic, for instance, that use semantic technologies to describe certain treatment mechanisms, interventions for cases. So it's great to describe a data space, and it's great to describe rules. And I think that is one of the areas where our current process description languages run into a roadblock. So we can describe what you can do in terms of a business process, but sometimes you want to describe conditional logic. Under which circumstances can I do this? So this would be a normal treatment for a patient that comes into the emergency room, but today is Saturday and it's a hot day, and maybe there are certain things that I know about the environment that help me diagnose this patient earlier and lead him onto a different path. So this interaction between rules and processes is to some extent uncharted, because if you talk to the business rules community, they will say, you don't need your process, all you need is rules. Yeah, if you have sufficient rules, then you know exactly what you need to do. And the business process community tends to say, no, 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 all you need is BPMN. And if you describe your processes detailed enough, then you don't need any rule descriptions because your processes basically look like big decision trees. Yeah? So the art form is to separate what's a decision, what is a rule out of the operational process and find the best description and the best way to link these two things. Yeah? So this is the sensing and the reacting part.
And I have a question. There is another project which has to do with innovation in technical areas. The idea is to try to, let me speak in Spanish, it will be clear.
Of course.
Otro proyecto en el cual se está trabajando con procesos de innovación. Concretamente el proyecto tiene que ver cómo inducir innovación en el desarrollo de productos tecnológicos. Y para hacerlo se está trabajando con una metodología que se basa también en modelamiento semántico, que fue desarrollada en Alemania, no me acuerdo la universidad, y que trabaja en base a reglas. Y lo que hace es codificar el conocimiento que existe en comunidades de innovación o innovadoras, como sería Silicon Valley, como sería Boston Road, o como sería algún sitio en Europa donde también se hace innovación. Entonces el conocimiento de esta gente que ha hecho mucha innovación, que ha resultado, se trata de codificar en reglas que se están tratando de ser aplicadas aquí en Chile para efectos de apoyar empresas que quieren hacer innovación tecnológica. Are you aware of any work like that?
I am not in terms of product innovation, but that might just be my unawareness of that. That doesn't mean that it doesn't exist here. The rules community or the area where expert knowledge is described mostly in the United States, I find it to be in the pharmaceutical industry, in the life sciences, very frequently because I have very, very complex data structures and I have ways how to combine them, but I have not seen it in this area of product innovation. As I said earlier, the Department of Defense has processes that haven't changed since 1914, so I'm not quite sure that their products are very innovative in many areas. But the one thing I want to say about rules is that there have been attempts at describing processes through rules in the 1990s, and one of these attempts is called the Generalized Process Structure Grammars, that basically says, if I only talk about constraints, then any process that does not violate any of my constraints is a legal process. And the distinction has been described as the distinction between maps and scripts. So we talk about process maps when we show the BPMN diagrams, but really what we're talking about are scripts because we show the steps that you go through, and we have these thin lines, which we call sequence flows, that say you can go from this step to this step, and that's all that you can do in that situation. And then there's a decision, and maybe you can go up or you can go down, but those are your only two options that you can do in that situation. And if you used a rule-based description, you could say things such as, after this activity has started, the next activity can start. And in BPMN, the assumption is only when the first activity ends, the next activity can start. So I can describe much more fine-grained behavior, and I can probably describe a process only around the boundaries. So I'm coming back to the maps versus scripts metaphor. So a BPMN process is a script that you follow, and if you lose your place in the script, you're probably not going to get to your destination. Yeah, you're only going to get to your destination when you follow every step in the script. When you have a map, and I had a map of Santiago, and I need to get from here to my hotel, there are probably multiple ways how I can get there. And if I get lost, then I try to find an orientation point, and based on that orientation point, I can plan again how to get to that objective. So I think there are processes in businesses where a script-based approach is appropriate. There are processes where you want to be standardized and you don't want a lot of creativity. Accounting is such an example. Yeah, you don't want a lot of creativity in accounting unless you want to be Enron. Yeah? But in the area where you're dealing with customer service, or generally services business, where you're doing something for somebody else and the customer becomes part of the value creation process, you want to retain flexibility. And BPMN is not good for flexibility. Yeah? BPMN tells you this is what it looks like. Yeah? And some rule-based system might be better for flexibility in those situations. All right. If there are no further questions, then thank you very much for your attention. Appreciate it.